Yeah, hi everybody.
Hey, hi, Vijay. How are you?
Good afternoon.
Hi, sir.
Hey, hi, hi. Okay, so what we are discussing yesterday, right? So we have covered the 2 days of the EIGRP classes, and yesterday we have seen that whatever the tables of the EIGRP protocol, how to configure the EIGRP, and also we have covered the basic fundamental with basic lab of the EIGRP, like how to advertise the route, what is the use of route ID, the concept of the route ID, like the election criteria of the route ID. Then we have seen the what is the autonomous system number. We have also seen that yesterday, right? The concept of the reported distance, advertised distance, or we can call it advertised distance. Then we have seen that called as a FD, this called the feasible distance, right? And then after that, we have seen that the concept of what we call, I forget the name, man. The packet types of the EIGRP. If you guys remember that, we have seen the 5 packet types of the EIGRP protocol. So the hello packet we had, right? And then we have seen that query packet. Then we have seen that update packet, reply and acknowledgement. So some packets are reliable packets. So whenever the packets are reliable, you will get the acknowledgement of that one. So update packet is a reliable packet, query packet is a reliable packet, and reply is a reliable packet. So whenever the router will send this packet, so you will get the acknowledgement of the packet. So EIGRP has a time is a hello time is a 5 second and 50 second. EIGRP maintains the 3 tables, neighbor routing into closing table. EIGRP use the multicast address dot port dot 10, right, to send the multicast packet. And then we have a neighborship criteria we have. So before the router is going to form the neighborship, or we can say that before the router is going to exchange the route, they need to first match the neighborship criteria. If that's going to match, then they will form the neighborship. And yesterday also we have seen that the key values concept. So basically EIGRP does use the interface properties to calculate the metric. And in the interface properties, we have a K1, K2, K3, K4, K5. The K1 is a bandwidth, K2 is a load, K3 is a delay, K4 is a reliability, and K5 is MTU. So by default, we are using the K1 and K3, right? So that's how we have seen this concept. And then also we have seen the successor route, that's known as a best route. And you have a feasible successor route, that's known as a second best route. So if you don't have a second best path, then you will see the successor route. If you have a second best path, then you will see the feasible successor route, right? So if the successor goes down, the feasible successor will become the successor one, right? Now, let me go in the little bit more detail. So basically, if I talk about the in EIGRP routing protocol, in EIGRP, let me, in EIGRP, in EIGRP, we have 2 types of route, right? One is called as a internal route, right? So when you use network statement to advertise the route, that route is called as an internal route, right? For the internal route, AD will be administrative distance, 90. Okay. Another type of route we have is called the external route, right? So when you receive the route from different domain, or we can say the different protocol, is called as a external route. For the external route, AD will be 170. One more type of route we have, right? So basically we call as a summary route. But majorly, if somebody will ask whatever the types of route we have in the EIGRP, we only have an internal, external. Summary route, when you do the summarization, right? When you do the summarization, then summary comes in the picture. The AD for this guy is 5. I'll come to the summary out later. First, understand the concept of this 2-1 because this 2 is very important, internal and external. So try to understand. Let me go with the topology in mind. So I have EIGRP basic. Right, let me power on the lab routers and let me check the putty side. I think my putty is 16 over there. Yeah, that's perfect. So I already have a IP configuration there. So it's the same configuration I did yesterday, right? So I think so I haven't saved my configuration yesterday. So let me save it again. So route between the two different A's. I'm coming to the Pradeep. Just give me a few minutes. Okay. I hope I have saved my configuration. If not, then we need to copy and paste it. What is this? Oh, I haven't saved this one. Okay, so router 2 we have, and let's go on router number 1 and check my IP configuration first of all. I don't have, so let me configure it again. So I have router number 1, and let me share this guy, and I have router number 2 now. And we have router 3 now. All good. Wait, come on. And we have router 4. All done. So we have a routers configured right now. Let's configure the router EIGRP protocol. So on the router number 1, we have this guy. So all they are part of the same autonomous system right now, right? All they are part of the same autonomous system number. So we already did this part 2 yesterday, right? If you guys remember that. So that's why I'm not explaining the main command right now. And here we go. R4. All done. So if you see right now, all this part of the same autonomous system number. So router 1 to the router 4, they are part of the same autonomous system number, right? So whatever the route that you can see between the router 1 to router 4, all you will see as a internal route. All you will see like a internal route. So let me color this guy. I'll put this as a green, and here we go. So whatever the route that you can see between the router 1 to router 4, they all are part of the same domain right now, same autonomous system node. So I can call this guys a EIGRP number 1. So whatever the route that you will see, for example, when router 1 is going to advertise this particular route, all this route on the router number 2, router 3, and router 4, you will see as a 9080. So if you check on the router number 4, do show IP route EIGRP, I can see that I have a 1.1.0.0 and /8 and 10.0/8 over there. This route has a 9080. This route is called as a internal route. Even if you see the show IP EIGRP topology, I'll put the 1.0.0.0, a detailed information for this guy. Right, what you can see that this route is called as what? Internal route. And for the internal route, the ED will be what? For the internal route, the ED will be 90 over there. Because I advertise this route through the network statement. So whenever you have a network statement, that route is called the internal route. And for the internal route, what happened? The ED will be 90 for this guy. But what happened if you have a route from the different domain? Different domain in the sense of what? Take example. I have a one domain till now, till this point, right? I call this guys a EIGRP number 1. And another domain we have. from here to here, right? So it means that on the router number 2, we are running the 2 domain right now. You can see that. I'll take this guy as a different color. And here we go, is pink one. So now you can see that this guy is running with the EIGRP number 2. Sorry. So understand the concept, right? So what I can do now, I'll just change the configuration. I'll go on the router number 2. I'll remove the EIGRP. No router EIGRP number 1. I'll remove the EIGRP from the router number 3. No router EIGRP number 1. And remove the EIGRP from the router number 4 as well. No router EIGRP number 1. And what I can do that, I'll change this guy into the 2 now. So on the internal route, advertised by network statement, right, has a AD90. External route comes from different domain or different routing protocol, has AD 170. So what I can do that, if you see the router 1 configuration, I'll see the router EIGRP number 1, I'll see the network, it's standard 1.12.0, right? As for the EIGRP router ID will be 1.1.1.1. Then we have a network 1.0.0.0. Then we have network 10.0.0.0. On the router number 2, guys, pay attention over there. Router 2 is running with the 2 different autonomous system number 1. One is running the router EIGRP number 1. I'll put this guy as a EIGRP router ID will be, or even I don't want to put it, that's fine. I'll put the this guy's see the network is like a 10.01 or 12.0, and I'll put this guy as a what? This guy. So this particular interface, if you see that, is going to be enabled in the EIGRP 1, and this particular interface is going to be enabled in the EIGRP number 2. So network to network, I have a 10.1.23.0, and here we go. Understood? On router 3, what we have, router EIGRP number 2, network 10.1. I can make this guy as alive simply 10.1.0.0. By putting the single line of configuration, I can address both the interface. And router 4, I have as the router EIGRP number 2, or even you can use the 0.0.0 statement. The 0.0 is just gonna tell you advertise all the directly connected route. This command is gonna enable all the interface. This command is gonna enable all the interface into the EIGRP routing protocol. But don't use this command line in the production network or not even the examinations. Never ever. You can use this command line, right, just for the practice purpose, but never ever use this command in the production network. In what case, what would you have to? I'm coming to the point, Gujar, 1 minute. So never ever use this one. Okay. Now, 2 different domains we have. So this is the configuration on the router number 2. We have router EIGRP and router EIGRP number 2. So obviously, if you have a 2 domain over there on the router number 2, this interface is the EIGRP number 1, this interface in the EIGRP number 2. What happened? You have a 2 different topology table over there. You have a 2 different topologies. So EIGRP topology table for the EIGRP number 1, and we have another EIGRP topology table for the EIGRP number 2. Now, in which case, right? So Bujar asked the question. Simple. The case is very simple. One company we have XYZ, and another company we have in the ABC. So when you have a 2 different companies, they are going to use the 2 different autonomous system number. So that's fine, because whatever the users are sitting in the company ABC, they can communicate to each other. Whatever the users are sitting in the company XYZ, they can communicate to each other. But now the situation is what? Try to understand. If you check on the router number 4, on the router number 4, you will only have information about the own company. You will only have information about the, let me copy paste this command, I haven't pasted. On router 2, in router 3. and order 4. So if you see on the router number 4, you only have information about the own company network. So if you just do show IP route EIGRP, if you see that on the router 4, you will have a 23.0 information. Can you see that? Even if you check on the router 3, on the router 3, you will have which information? You will have only own information. Can you see that? These all are called as internal route we have. 9080. So on router 3, you have information of this guy. But do you see the information from the company XYZ? No. If you check on the router number 2 right now, on the router number 2, what happened? You will have right? You will receive all this information in the which topology table? In EIGRP topology table 2, right? And from this side, you will also receive this information from the EIGRP topology table 1. It means that only the router number 2 is a router that has a complete information. So I say the raso IP route EIGRP, you can see that I have a route from the 1.0 that's coming via the 12.1, and I have a 10.0 that's coming via the 12.1 again. Okay, what on this is coming on the 34.0. Hold on, guys. Let me, I think so, do show also in which I'm using it. I'll explain you the meaning of this command line. Hold on, guys. Don't worry about that. So by default, these features are disabled nowadays. I don't know how it's enabled on the startup. On the new iOS order, it's disabled. Right? So you can check on the router number 2 right now. Do show IP route EIGRP, guys. What you can see that. I'm not. Do show IP interface brief. Oh, my network is 11.0.0. Sorry, I thought it's a 10. Yeah, I'm getting now. Right? Now understand the concept on the router number 2. Router number 2 is the only router, right, that has a both information, that has a company XYZ information, and that has information of the company ABC. Only the router number 2 router. So we can call this router as a what? We can call this router as a border router. We can call this router as a border router. Because why I call this as a border router? Because it is participating into the EIGRP number 1 and it is participating in the EIGRP number 2. There's no issue right now. Okay, but you know what happened? Now company XYZ, right? The company XYZ has acquired the company ABC now. The company XYZ has acquired the company ABC. So now it's totally become the what? Now it's totally become the XYZ company. Okay, acquisition has done, right? We acquired the company XYZ has acquired the company ABC. Now it's become the company XYZ. But there's still the problem is what now? See, payment has done, all the what we call documentation has done, but the issue comes in the picture, the network side. The network side is what? I still don't have a communication from here to here. End-to-end communication is still not there. Can you check on the router number 1? Do I have the information of the router 4? No, I don't have. Check on the router number 4. Do I have this information for the router number 1? I don't have. Only router number 2 has the information. But the problem is that router number 2 is receiving this information from the router number 1, these information, right? But router 2 is not sharing this information to the EIGRP number 2 domain. Same way, router 4 is sending this information to the router 3. Router 3 is sending this information to the router number 2, but router 2 is not sharing this information into the EIGRP number 1. So EIGRP number 1 is not sending the own information to the EIGRP number 2, and EIGRP number 2 is not sending the own information to the EIGRP number 1. You have an information like this right now, 1.0.0.0 in the EIGRP number 1, and you have 11.0.0 in the EIGRP number 1. Same way, you have a 4.0.0.0 in the EIGRP number 2 and 44.0 in the EIGRP number 2. Of course, you will also have this information as well, but I'm not writing this information, right? Understand the concept. But between the two different autonomous systems, we are not exchanging the information. Acquisition has done, we did acquire the company, we did all the paperwork, but still users are not able to communicate. So what we have to do that, we need to exchange the route from the EIGRP1 to the EIGRP number 2 and EIGRP2 routes into the EIGRP number 1. It's same like a inter-VLAN routing. It's same like a IVR inter-VLAN routing that we did. To exchange the routing information, we call this guys a redistribution. So when you're gonna exchange the routes from one autonomous system number to the different autonomous system number, this is the one autonomous system, this is a different autonomous system number. So when I'm gonna exchange the route from the one autonomous system number to the different autonomous system number, that mechanism is called as a redistribution. In layer 2, we call as a inter-VLAN routing. In layer 3, we call as a redistribution. So what we can do over there, I just need to go under the EIGRP. You need to do this redistribution on the router, which is the border router. It's not like that I can do the redistribution on the router 3. I can do the router 4, I can do the router 1. You need to find the router who has a complete routing information. Who has a complete routing information. The router who has a complete routing information, only on that particular router you can call as a redistribution. You can configure as a redistribution. So I need to go on the router number 2 and I'll say that, hey, listen, under the router number 1, EIGRP number 1, you need to call, so understand the concept like this way. Redistribution is a guy, okay, is a person, right? You need to call the redistribute. And which I'm going to call? I'm going to call the EIGRP number 2. Understand the concept. What I did, I went under the EIGRP number 1. Okay, I'm the network engineer. I called the EIGRP number 2 routes into the EIGRP number 1. I went in the EIGRP number 1. I call the EIGRP number, all the 2 routes into the EIGRP number 1. So under the EIGRP number 1, I'm calling the EIGRP number 2 routes. Done. So now if you see, if you go to the router number 1, all these routes, right now the EIGRP 2 routes comes in the EIGRP number 1. So if you go in the router number 1, and if you put the command do show IP route EIGRP, you can see all these routes comes like an external router. D external 17080. But you will not have a routes on the router 4 right now still. The reason is that now the network engineer will go in the EIGRP number 2, right? And what he will do that, he will call the EIGRP 1 routes into the EIGRP number 2. So first of all, you need to go under the EIGRP number 2. The network engineer first move to the EIGRP number 2 and then call, I call redistribute EIGRP number 1. That's all. And now I can check on the router 4, I have information as a D external. And if you see the show IP route EF, show IP EIGRP to proceed 100.0.0.0.0, you can see that this route is called as a external route. And external route has a AD value is what? 170. Please give me one. Let me disable the WhatsApp message. Okay. So this is called as what? External route. And for the external route, what happened? The AD will be 170. And you can see that we have an external data. It means that this route that we can see over here, this 100.0 information that I'm getting from where? I'm getting from the AS number 1. So I'm present on the router number 4. I can see that this route is actually coming from, AS number 1. So that's called as an external route. So this is the concept of what we have a same protocol, but different AS number. Same protocol, but different AS number. So route from the different region AS is called external, right? Exactly right. So this is called the same autonomous. So this is the same routing protocol, but different autonomous system one. But what happened if I'm going to use the different routing protocol now? Maybe I'll use the RIP protocol. Maybe I'm going to use the RIP protocol now. So in the RIP case, what happened, the scenario will be different now. So let's do the configuration for the RIP. So I'm now going to do the redistribution. So here we have to do that. Let me write on this way. Redistributing between EIGRP1 to EIGRP2 and vice versa. Now we have what? Redistributing. Guys, I'm giving all the possible scenarios. Just please pay attention. Redistributing between EIGRP to RIP and vice versa. So on the router number 1, same configuration. I'll just copy and paste it. Till the router 2, we have a same configuration, right? On router 2, what we have to do that we need to run the RIP protocol. I'll go with the version 2. So let me explain you. The RIP is a distance vector routing protocol, right? Distance vector routing protocol. So before the EIGRP, we had a RIP protocol. Nowadays, very rarely you can see the RIP protocol. I can say the 1% you have a chance to see the RIP protocol, right? And the RIP has a 2 versions, version 1 and version 2, right? Version 1 was the classful, and version 2 is the classless, right? So version 1 only support the classful route, whereas the version 2 can support the classful and classless route as well. So the people are in the production right now. If you see, they are running with the version 2, they are not running with the version 1. There's many reasons behind it. So how you can enable the version 2? I just put the version 2 and say the network 10.1.23.0, right? In order summary on the R3. I see the router EIGRP, sorry, router RIP protocol, version 2 network 10.1.23.0, network 10.1.34.0. No auto summary. Hold on, you will understand the meaning of this command, no auto summary. By end of the today class, you will understand the meaning of this command line. 34.0 and network 4.0.0.0 and network 44.0.0. All done. So let's go on the router number 2 now. On router 2, we just need to configure this guy. So let me remove the no router EIGRP number 1 and not 2. And I'll configure this guy like this. Same thing on router 3 now. On router 3, we need to remove the EIGRP number 2. And we have a different protocol. And same way we have a R4. Configure no router EIGRP number 2. And we have this guy. Right? Now, understand the concept again. So what happened? All this route that you can see, the RIP is company XYZ is running with the. Now both are the same company. So previously it was a ABC. The company XYZ has acquired the ABC. So now it becomes the same company XYZ, but the protocol are different because previously the company ABC was running with the RIP protocol. Now we need to provide the communication between the subnet to the subnet. So what happens? So if you see on the router number 2 again, on the router number 2, if you put the command so IP root, I can see that this 4.0 and 44.0 route is coming by the RIP protocol, R4 RIP, that has a AD value 120. And RIP protocol is using the metric as a hop count. Hop count you can consider as a router. Hop count you can consider as a router. One router as a one hop count. One router as a one hop count. So if you see on the router number 2, how many hops this route is away? One hop and one hop. 2 hops is away. Right. So on the router number 2 perspective, one hop, 2 hops away, this route is there. 4.0.0.0. The maximum hop count of the RIP protocol is what? 50. It means that if you're running with the, understand the concept, guys, if you're running with the RIP protocol, you can only have a 15 routers. You cannot go beyond that one. If any route is coming with a 16 metric, if any route is coming with a 16 hop count or metric, that route will become the unreachable route. So you cannot send the traffic to this particular network. It means that that route is called as a down route, simple language, which the route is not available now. You cannot send the traffic to this particular network because it's unreachable now. Sometimes it's called the infinity metric. Infinity metric means what? This network is down. So maximum we can have only 15. That's why saying that RIP is not a good protocol. You cannot deploy this protocol for the big network. You can deploy for the internal small network, but you cannot go with the big network. But the problem is what right now you can see that I have a router 2 also getting the route from the EIGRP, right? But if you check on the router 3 right now, router 3 is only having the route from the RIP protocol. They don't have a route from the EIGRP. If you see on the router 3, I only know about the RIP routes. R3 doesn't know about the 1 and 11.0. So it means that I cannot send the traffic from here to here. So there will be no communication because router 1 doesn't have a route of the 4.0.0.0. If you see do so IP route, I don't have a route. R1 doesn't know about the 4.0. R4 doesn't know about the 1.0.0. So it means that there will be no communication. So what do you have to do that? Simply, it's the same concept. So here you have a EIGRP, here you have a RIP protocol. So in the EIGRP, you have a 1.0.0.0 and 11.0.0.0. Of course, you will also have a this route. So I'm just considering the loopback because I don't have a space over there. Same thing in the RIP part. In the RIP part, what happened? You will have a same 4.0 and 44.0. Again, you will also have this route, but I'm not considering it because I don't have a space over there. Now we need to exchange this route. So again, this is the border route because this router has a contains all the routes. We need to do the redistribution only on the border router, not the other routers. So in that case, what you can do that you just need to go on the RIP. Any mode you can go it. Either you can go in the RIP, either you can go in the EIGRP. It's up to you. So I'll go in the EIGRP mode. Right. So just go in the EIGRP mode now. I'll say that router EIGRP 1. And then what I will call to call, right? To call the RIP protocol, what command I have to use? To call the RIP protocol, I need to use the redistribute command. And what I'm going to call? I'm going to call the RIP protocol. So I just need to call the RIP. So whatever the route version in the RIP protocol, bring into the EIGRP. Now wait a minute. Now wait a minute. If I'm just going to put this command redistribute RIP protocol, then what happened? Whatever the RIP route, because RIP use the metric as a hop count. EIGRP use the metric as a key values, bandwidth and delay. Remember? Bandwidth and delay EIGRP, RIP has a hop count. So if the hop count route is coming into EIGRP doesn't understand the hop count, right? EIGRP doesn't understand the hop count. So what you have to do deal this guy, whenever the route is coming from the RIP protocol into the EIGRP, you need to change the metric for that one. So I will say the key values. So the key, I'm going to use you can use the any value. So the key one, I'm going to use anything. I will use the 1. K2, I'm going to use the 1. K3, I'm going to use the 1. K4, I'm going to use the 1. K5, I'm going to use the 1. You can use any number. It's up to you. So normally, what is recommendation to use it? The recommendation to use it, right? So practice purpose, you can use the K1 as a 1, K2 as a 1, K3 as 1, K4 as 1, K5 as a 1, right? But recommendation is what? So interface 0/0. So recommendation to use what? You need to use the default values. See, normal behavior, I can use anything. So right now, I'll show you this behavior right now, the normal behavior. Then I'll come to this behavior as well. Don't worry about that. So these are the key values I'm saying that. So whatever the RIP protocols has route as a hop count. So whenever this hop count route is coming to the EIGRP, I will change the metric from hop count to the key values. Same thing, router RIP protocol. And now I need to go on the RIP protocol. right? Under the RIP protocol, what I will tell this guy, hey, call the EIGRP. Call the EIGRP. Now, when I'm going to call the EIGRP, understand the concept. This EIGRP is using the key values, right? But a RIP doesn't understand the key values. Then you need to define what? The metric. So what? So whatever the EIGRP routes comes into the RIP protocol, I will use the hope count. I will say that any hope count, but don't use the maximum hope count, because the maximum you have a 15 hope count, right? 16 will become unreachable. So better to use the lower value. So I can use a 1. Take example, if I'm going to use the 15 over there, then what happened? He will advertise the route with the 15. He will receive it. But he cannot advertise to the another guy, right? Because 16 will become unreachable. So better to use the lower value always. So now you can put this command on the router number 2, and you will see the route exchange. I haven't put the EIGRP number 1. So this is the AS number 1, and this is the metric values we have. Spelling is missing. RIREDISTRI. RILDSTRI. All good. Now you can see on the router 4. Previously, I had not information about the 1 and 10. Now I have. Can you see that? All the router 4 has a RIP route. So all this route is converted into the RIP now. Right? So I say the metric. So when router 2 is going to advertise the EIGRP route, use the metric is 1. So when router 2 is advertising this route to the router 3, 1, and then 1, 2. Same way, if you check on the router number 1, do show IP route EIGRP, do show IP route, I can see that I have external route from the router 4. And that using the EIGRP metric key values. So if you have a RIP and EIGRP, then you can do this way. But take example, what happens if you have a OSPF now? Right? Take example if you have a OSPF now. So don't worry, I'm not gonna explain how the OSPF is gonna work right now. I'm just showing you the behavior. What happens if you have a OSPF? Then the configuration will be changed. So let me remove the RIP from there. No router EIGRP main. No router RIP and no router RIP. Now let's take example of the OSPF. What you can do that? I'll simply call this guy over here. Now the redistribution. Between EIGRP to the OSPF and vice versa. So same R1 will be there. R2 will also same over here. R2 will also have a router OSPF number 1, right? I'll explain you this meaning of this command line. Don't worry about that in the OSPF protocol. Let me configure this thing. Area 0. Now 3 we have. If you know the OSPF, then it's fine. Otherwise, leave it this part. Okay. Oh, not okay. All the simple command. Right. So let's do on the R2 now. On the R2. Because I haven't removed the configuration from router number 1. I just removed from the router number 2. So I'll copy and paste, and R3 as well. R4 as well. So what happened? R4 will form the neighborship with the R3. R3 will form the OSPF neighborship with the router node 2. But route extend will be not there. So this ABC company is running is now protocol is called the OSPF protocol. XYZ is running with the EIGRP, but XYZ company has acquired the ABC now. But still my network has not synchronized. So now we need to synchronize the network. How we can do that? We need to do the registration on which router? A border router. Who is the border router? Router number 2 is a border router. So if the router number 2 is a border router, what you have to do that? You need to go on the router number 2 and do the registration. How? Let me show you the command now again. Same way, I need to go under the EIGRP protocol and what we call this guy, redistribute. Now what? I need to call the OSPF route. Right? What is the OSPF process ID they are using? It's a 1. And here I'm going to define the metric because OSPF use the metric as a cost. So when the cost comes into the EIGRP, we need to define in the EIGRP values, key values. So what key values I'm going to use it? Bandwidth. So I'll better do one thing. Do show interface 0/0. What's the bandwidth we have? 10,000. Let's put the bandwidth over there, 10,000. Then K2, delay. What is the delay over there? It's 100. So 100 is a microsecond, guys. Please pay attention. 100 is a microsecond. Configuration you are always doing in the second. So if you're gonna say that 10 second, right, it will say the 100 microsecond. If you say the 100 second, then it will say the 1000 microsecond. So this is the second, this is the microsecond. So the configuration always you're gonna do in the second, they will convert into the microsecond. So I'll say that 10 now. Reliability, always gonna go with the 255. That's always better reliability. Load will be 1, of course. Lower load is always good. And the MTU will be what? It's a 1500. So this is the recommendation way to define the metric, right? When you're gonna redistribute it. But again, you can use anything. And now same way, exit and data OSPF number 1. I'll say the redistribute which protocol? I'll say the EIGRP number 1. And same thing, metric will be what? I say the metric will be anything. I have a use range, I guess that will be. That's fine. Leave this part right now, this error message. We'll discuss this error message in the OSPF protocol. So on router number 2, what I did, I went to the router EIGRP and I called the OSPF protocol. When I call the OSPF protocol, I define the metric value for those guys. Same way, I went to the OSPF and I called the EIGRP 1 and I said the metric will be what? 20. So now you can see on the router 4, you will have all the do show IP route. On the router 4, you can see that I have a route. Don't worry about that E2 right now. What is E2 and E1? This is comes in the OSPF. Focus on the router 1 in the EIGRP mode. So in the EIGRP, if you see do show IP route EIGRP, I have an external route, and that external route has an AD value 170. So who is doing the redistribution? So if you see the show IP EIGRP topology, so you can see that this route is known as the external route. I'm on the router number 1 right now. Okay, this route is external route. This route I'm getting from the OSPF protocol. All right. And who is the originator router? It means that who is doing the redistribution? The redistribution is done by the 23.2. Who is 23.2? 23.2 is the router ID of the router number 2. 23.2 is the router ID of the router number 2. So if you check on the router number 2, do show IP EIGRP topology table, the router ID of the R2 is a 23.2. So you can also verify from where I'm getting the route. So if you want to perform the troubleshoot, you can easily do the troubleshoot like on the router number 2. So router number 2 is the baud router. So doesn't matter, man. What I'm saying that if you are getting the route from the same domain, same behavior, I have shown you that 3 behaviors, right? Like a router 1, a router 2, and router 3. So EIGRP number 1 and EIGRP number 2. In both the case, what happen? You will have an external route. Even you have a OSPF in EIGRP, you will have an external route. Even you have a RIP and EIGRP, you will have an external route. So every time you have, whenever you get the route from a different routing protocol into the EIGRP, you will see as a external router. Anybody has a question in the external? Now you can ask me. Internal external is killer. That's why I mentioned that different domain means. So whenever you're gonna use this keyword, it means that different EIGRP domain, or we can call it a different routing protocol. So whenever the route is coming into the EIGRP from the different routing protocol or different domain, you call that route as an external route. You guys, anyone has questions?
Yeah.
Yeah.
In the top, can you go to the topology, the router?
Yeah.
In GNS. For example, in router 1 and router 4, let's consider, I mean, we are merging two companies, but we are not aware of the opposite company's LAN network. What if our router's LAN network and the merging company's LAN network will be the same, like L1 in both 1.0.0.0?
Okay. Yeah, great one. And this also will be 1.0.0, right?
Yeah. How it will be?
So in
You
that case,
can't.
in this case, normal communication will not happen. Normal communication will not happen in that case. So what happened? Understand the concept. So when router 1 is going to send this route to the router number 2, he will send the route as a what? EIGRP. What will be the 80? 90, right?
Yes.
Okay. When router 4 is going to send this route to the router 2 as a 1.0.0, what will be the 80 for this guy? OSPF 1110.
Correct.
So what router 2 will do that? Router 2 is getting the 1.0.0 from the EIGRP and 1.0.0 from the OSPF. This guy's a 90, this guy's a 1110, right? So router
Yes.
2 always give the preference to whom? Lower
Lower
80.
one.
But again, now just you told me that, right? No. So normally this scenario, is not suitable. But take example, what happened? We have one site in the Delhi, and that has a, because the private IP, right? The private IP could be the duplicate, because 10.1.1.0/24 and 10.1.1.0/24. So one site in the Delhi, another site in the Mumbai, right? And I want to provide the connection between these two sites, but both are using the same subnet. In that case, what happened? Then one of the advanced feature of the NAT is coming. With the help of NAT, you can provide the communication if you have a same subnet. But that the scenario that you gave me, in that case, no communication will not happen. Only router will pick the only one router as a test based on the lower AD. Yeah. What are advantage and I don't, what are advantage and disadvantage of router 2? What is the meaning of router 2 disadvantage? Firoz, you got the answer, right?
Yeah, bro.
Okay, great. So in this case, what happened? The 1.0, if you have, you will only receive the either the EIGRP, either the OSPF over there.
No, in the real scenario, what will be the solution? We need to change this whole subnet
So
of any one of
either you need
the.
to change the whole subnet, either you can do the NATing.
Okay, got it. Thank you.
Okay, so this is how you can do the internal external, right? Next type of route, again, I'm telling you guys, this route that you can see that summary, right? Summary route, we call as a summary route. On the local route, we call as a summary route. Understand the terminology right now. On the local route, we call as a summary route. But on the neighbor router, we call as a internal router. I know this is a little confusing. I'll explain you. Don't worry about that. Take example. We have router number 1 and we have router number 2. Okay, before I'm going to explain this part, let me explain you the first thing is very important. What is summary? So what do you understand from the summary? First, tell me. What do you understand from the summary? What is the meaning of summary? What is the meaning of summary? Take example. This is the one of the book I have. And what you can see that I have a BGP routing and what's the page number? You can see that it's a 55 over there, right? That's the first chapter of the BGP. Chapter 1, 55 page number. Go to the last page right now. And if you see in the last page, you have something called the foundation summary. What's the page number is now? It's a 174. So if you just gonna minus, right, 174 minus 55, 199 we have. So the difference is the 199. And if you see the foundation summary, the first page we have, the summary page. Then we have a second page. Then we have a third page. We have a fourth one, fifth one. That's all. So what I'm saying over there, understand this concept. The 119 page we have, 119 page we have. In this 119, someone might is on guys. 19 page, what happened? We have a detailed information. We have a detailed information. In the last, what happened? We have a just of 5 pages. In the 5 pages, what happened? We have a concise information. A concise information we can call as a short information. Right? Same like that, I'll tell you. We have a 255.255.255.0. Right? You call this guy the subnet mask. Right? But at the same time, we have another ways to define the subnet mask is what? /24. So this is the call what? Detailed information. And this is called what? Short information. Right? Concise way to represent the subnet mask information is called as a CIDR value. Same way, we have 199 pages of the detailed information we have for the BGP protocol. Same in the 5 pages, what happened? We have a short information for the BGP now. So we have converted the 119 page of information in just 5 pages of information. We have converted 199 pages of information into the 5 pages. This is called what? Summary. Let me tell you another example. Your resume, right? Your resume is what? It's a summary information of your life, what you did in the last 25 years. Then you're going for the resume and say, okay, this is my resume for the 1 pages and I'm giving all my 25 years of experience in just a single page. Once you have a 30 plus of experience, 35 years of experience, then you will make 2 pages, right? But can you see that what's happened? Based on that 1 pages and 2 pages, right? Your recruiter can identify, are you suitable for this job or not? So what is the benefit of the summary? The benefit of the summary, if you see that, I can see my time. Based on this 5 pages of information, I can easily identify what kind of information are present in the 119 pages. Based on the 2 pages of resume, I can identify what sort of knowledge you have and what sort of knowledge you have gathered in the last 25 years. Guys, someone mic is on, please be on mute. Right? So that's a beauty part of the summary. Summary is always a good thing, right? Because it saves your time, it saves your process, it saves your memory too. Same summary part we can do in the networking as well. Same summarization we can do in the networking as well. Try to understand. Take example, we have a router number 1, right? And we have a router number 2. and we have router 1, and we have router 2, and this guy network we have a 10.1 dot. So 12.1 I can make this guy, and I'll make this guy a 12.0/24. This guy is 12.2, right? And I have some network behind this guy router 1. I'll say that 10.01/24, 10.01.2.0/24, 10.01.3.0/24, 10.01.4.0/24, 10.01.5.0/24, 10.01.6.0/24, right? And I have another network is called what? 172.16.0.0/16, right? What I can do that, I'll just go on the router EIGRP, router 1. I'll say that router EIGRP number 1. I'll say the network 0.0.0. It means that I'm going to enable all my loopback over here. Whatever the loopbacks we have, I'm going to enable all the loopbacks. Same thing on the router number 2. I'm going to enable all the interface. So interface we have 0/0, right? Interface we have 0/0. So we have a few loopbacks over there. Guys, please pay attention. These things we are not going to discuss the same thing in the voice protocol, not in the BGP. Loopback 7 we have now, right? 7 loopbacks we have. So what happened? Router 1 is going to share all this information to whom? Router 2. Router 2 is going to maintain all this information in the EIGRP topology table, right? So in that case, what happened? Take example, if this guy is going to consume the 200 bytes of memory, this guy is going to consume the 200 bytes, this guy is going to consume the 200 bytes of memory, this guy is going to consume the 200 bytes of memory, also 200 bytes of memory, 200 bytes of memory, and this guy is also going to consume the 200 bytes of memory, right? So total is what? 7 into 2 is equal to 1400 bytes of memory. The router 2 is going to consume for all these router. 1400 bytes. It's not a less memory, it's a huge memory. What do you think about the router? Understand the concept. This is the guy of the router. What do you think about this router? Does router only maintain the routing table? Does router only maintain the router only for the packet? No, dude. Router doesn't mean that only maintain the routing table and routing protocol. Router has a lots of work. Router can do the NTP, router can do the SNMP, router can do the syslogin, router can do the MPLS, router can do the VPN, router can do the layer 2 VPN, many tasks that router can perform. And each task that you're going to do on the router side is requires some amount of memory and CPU as well. And if you're just going to put the router as a dedicated router, I said, hey, you're only going to maintain the route. It's not a worth solution, right? So what I can do that, because it's going to consume my lots of memory, I can summarize, right? I can convert all this route into the single route. So instead of sending the 7 route, what I can do that, I will send the 1 single route. I will see that, okay, let me send the 10.1/8. So maybe you have a question, hey, Law, why you are not summarizing this one? See, summarization only will be done for the contiguous network. Contiguous means what? Same part. Can you see that 10.1.0, 10.1.2.0, 10.1.3.0, 10.1.4.0, 10.5.0? This is a different subnet. This contiguous network we have. So only we can summarize this part of network we have. So now what happened? Instead of going to maintain this information, now I'm going to maintain what? How much memory I'm going to consume now? For this guy and for this guy. Total is what? 2 into 2 is equal to 400 bytes of memory. So previously I was maintaining the 1400 bytes. Now I'm going to maintain the 400 bytes of memory. Can I send the traffic? So whatever the users they present over there, they can send the traffic to all this particular network. There is no issue in the traffic. I can save my router resources. I can save my bandwidth. I can save my CPU. I can save my memory too. So by doing the summarization, right, what I'm doing that, saving my bandwidth. Now you have a question, how I'm saving the bandwidth? Of course, if I'm not going to send the all information on this particular link, I can save my bandwidth. Previously, I was sending the 1400 bytes of information. Now I'm sending the 400 bytes of information. I'm saving my what? See my router CPU. see my memory of the router. And the good thing about reduce the size of routing table. Can you see that previously I was maintaining this amount of size of routing table? Now I'm just going to maintain this amount of size of routing table. So multiple benefits you have by doing the summarization. In production network, right? Always you are doing the summarization. ISP always take the summary route from you, not the complete routes. Take example, if the ISP is gonna take all the individual route, then what happened? The ISP routing table will be huge. That's why ISP always suggests the customer, please send the summary route, not even suggesting them. ISP always, there's a policy is there, is always take the summary route, sort information. Understood? So summarization you can done in the 2 ways, right? Summarization you can done in the 2 ways. One is called as a auto summary. Another is called as a manual summarization. So of course, there's a name suggests that it's a auto summary is what? Right? Auto summary means what? Automatically summarization will be done. Manual means what? You need a network engineer. So in this case, you need a network engineer. In this case, you don't need a network engineer. Auto summary, the problem with the auto summary, it convert classless route into the classful. Simply, that's the meaning of auto summary. You cannot do the summarization of classless route in auto summary. You cannot do that. So if you see that all these are my classless route was summarized into the classful. All these are my classless route is summarized into the classful. So auto summary you can enable and disable it. So if you put the command router EIGRP number 1 and I say the auto summary, it means what? Please do the summarization. So it means that this network will be converted into the single one. So right. So this network will be converted into the single one. So auto summary is what? Please do the summarization. So this network classless route will be converted into the classful one. It convert the classless route into the classful. That's the meaning of auto summary. You cannot do the summarization of the classless route. Sorry, I'm so sorry, my mistake. You cannot do the summarization of the classful route. Sorry, my bad. Classful route. So for example, if you have a network like this on the router number 1, take example, we have a 191.1.0, right? We have a 191.2.0 and 191.3.0. You cannot do the summarization for this guy. You cannot convert this 3 dot into the single one. You cannot do that. You cannot convert this 3 dot into the single one because auto summary doesn't have a concept to convert classful dot into the single one. You cannot do the summarization of the classful dot. And when I say the no auto summary, take example. If I want to say that no auto summary means what? I want to disable the summary, right? I want to disable the summary means what? Don't summarize. So this command is going to enable the summarization. Right? This command is going to disable the summarization. So if I'm going to disable the summarization means what? Don't summarize it. So it means that all these route will be advertised as a individual route. So there will be no summarization now. So no class less will be converted into the classful. No classless will be converted into the classful. Normal route will be advertised. right? But we are nowadays, we are not using the auto summary because auto summary create the loop. Auto summary create loop in the network. We are not using the auto summary. So by default, nowadays, whatever the newer iOS version is coming, all the newer iOS version has a no auto summary enabled. Because if you're gonna enable the auto summary, you will have a loop in the network. How? Let me explain you. Take example, how the auto summary is gonna create the loop. We have router number 1, we have router number 2, and we have router 3 as well. So we have a network behind this, guys, so 192.1.0. Take example, we have a 10.1.1.0/24, and this also have a 10.1.2.0/24. See that both are a different subnet right now. But what happened if the auto summary is on? If the auto summary is on means what? Enable. If the auto summary is on, it means that enable. If the auto summary is on, it means that it's enabled. Then what happened? In that case, router 1 is going to send this information to router 2, and router 3 is going to send this in router 2. So he will send like a 10.0.0.0/8, and he will send like a 10.0.0/8, because auto summary is what? Convert the classless route into the class pool. They convert it, classless route into the class pool, convert it. So what R2 will do that now? R2 is going to maintain the 10.0.0/8 by the router number 1 and 10.0.0/8 by the router number 2. So router 3. So when I say the ping from the router number 2, 10.0.1, so 10.1.1.1, then what happened? To whom I'm going to send the traffic? 50% traffic will go by the router number 1, 50% traffic will go by the router number 3. The loop comes in the picture. That's why it is always a recommendation, right? That's why it is always a recommendation to disable the auto summary. We are not using the auto summary nowadays. If I'm going to disable the auto summary, then what happened? If I'm going to off this guy, then my network will be something like this thing. Then my network will be. So let me explain you. With auto summary enabled, my network like this way, 10.0.0.0, my next hub will be router 2, and 10.0.0.0, my next hub will be router 3. So 50% traffic will go the router 2 and 50% traffic will go with the router 3. But with auto summary disable, then what happened? On router 2, we have a 10.1.0.0 router 2 and 10.1.2.0 router 3. So this will be the difference over there. So now if I'm going to send the packet to the ping 1.1.1.1, understand the concept, then what happened? If the auto summary is disabled, then I'm going to send the packet to the router number 2 only. So that's why auto summary nowadays, right, it's disabled by default. So you have two ways to do the summarization. One is called the auto summary. By default, nowadays in the newer iOS, it's disabled. If I talk about the older iOS, it's enabled. So if you check on the router number 1 right now, if you see show IP protocols, you can see that disabled. Why it's disabled? Because I manually configure this command. If you see show run section EIGRP, okay, I haven't configured it. So it's I think so which version I'm using right now. 15.0 then it should be disabled. Yeah, it's a 15.2. So if you're going to use the 12.0, you will see the enable over there. So how you can enable it? You just need to go down to EIGRP number 1 as the auto summary, and then show IP protocol. It's enabled now. So auto summary is gonna enable the summarization. Auto summary is gonna, or no auto summary is gonna disable the summarization. So to avoid this problem, right, looping problem, right, to avoid the looping problem, we came across with the manual summarization. Manual summarization. See, this summarization you're going to do under the EIGRP mode. This summarization you're going to do under the EIGRP. You need to go under the EIGRP mode and say that no auto summary and auto summary, depend on the requirement. But make sure that it is always disabled. Don't enable this thing. Never ever enable this thing in the production network. Never ever. It's going to create the loop in the network. Another way summarization we have is called the manual summarization. Manual summarization you are doing on the for interface level. You can do the manual summarization for class pull down and classless routing. So we don't have any such issues in the manual summarization. So whenever the manual summarization comes in the I'm sorry. So my internet get flapped. So when I say the manual summarization, right? So manual summarization you're going to do on the interface level, and you can do the summarization to the class pull and classless route. Make sure that manual summarization, this configuration will be changed depending on the routing protocol. In a OSPF, we have a different ways. In a BGP, we have a different ways. In a DEP, we have a different ways. Again, auto summary is not supported by the all routing protocol. Auto summary we have in the DEP protocol, we have in the EIGRP, we have in the BGP. OSPF does not have a concept of the auto summary. But all the routing protocol has a concept of the manual summarization. These are the few things, okay, that you have to keep remember, because these things will be hit on the interview. Sorry, in the interview. So now how you can do the manual summarization. So take example, I'm going to do the perform the manual summarization for this particular network, right? I'm going to do the manual summarization for this particular network. How you can do that? So let's take example. I have a 2 dot router 1 and router number 2. And I'm going to do the summarization for this guy. Few networks I have. I have 12 router 1, 12 router 2. And let's take example. I have a loop backs of the router number 1. 191.0/24. That's loop back number 1. Loop back number 2. Loop back 3. Right? 3 loop backs I have, right? This is the interface we have 0/0. This is the interface we have 0/0. What configuration we did on router number 1? I said router EIGRP, 1 network. I'll call this guy a 12.0. I'll call this guy a 1.0. I'll call this guy a 2.0. I'll call this guy a 3.0. Same thing on the router number 2, we need to do that. So on the router 2, we just have a one configuration on one route, 12.0. Right? Now, after doing this thing, what happened? Router 2 will send all this individual information to the router 1. After doing this thing, what happened? Right? After doing this thing, router 2 is going to send the all information to the router 1. It's that way. Like this way. So you have a 1.0, 2.0, and 3.0. right? This way you will send that out to the router. It's a before summarizing, right? It's before summarizing. Summary. What I can do that, I just need to convert this 3 dot into the 1. So to convert this 3 dot into the 1, there is a rule. Rule is what? Let me write on this thing first of all over here. Summary part. EIGRP support 2 types of summarizing. One is called as a auto summary. By default, in the new ISP, come on, auto summary is disabled, but in older, it's enabled. Auto summary only do the summarizing for classless, not for the class B. Right? How you can enable and disable? No router gauge auto summary, it's gonna enable the connect, and router gauge number 1, it's gonna disable the auto summary. Then we have a manual summarizing. And do manual on a for interface basis. Right? The good thing about the manual summarizing, you can do the manual summarizing for class full and classless network. That's really nice. How you can do the manual summarizing? So to do the manual summarizing, you need to follow the steps to do manual summarizing. The first step we have what? Step number 1, write down the networks. We have a 1.0, 2.0, 3.0. Step number 2 is what? Write down the details of these route, or we can convert it into the binding. Right? Simple language, like how we did the summating. So for the 192, what's the binary of this guy? 192. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Right? To do a 0, to do a 1, to do a 2, to do a 3, to do a 4, to do a 5, to do a 6, and to do a 7 we have. How you can do the summarization for this guy? What is the binding for the 192? The binding for the 192 will be 1 and then 1 0 0 0 0 0, right? 6 7 8, of course, right? So the binding of the 192 will be 1 1, and the 128 plus 64, it will become the 192, right? The remaining will be go 0 0 0 0. Then the binding of 162 will be what? 168 will be what? The binding of 168 will be 128 plus 0. I cannot add the 64. If I'm going to add the 132, it will become the 160. I cannot add the 16 over there. I can add the 8, and then remaining will be 0. 1 0 1 0 1 0 0 0. Then the binary of course, simple one. The 1 will be, last value will be on 5 6 7 8, and the binary of 0 will be 0 0 0 3 6 7 8. Same values. The binary, this is the binary for what? Then we have binary for 2, binary for 3. Now what you can do that? You need to find the, right, you need to find the matching bits. Let me little break it. So you need to find the matching bits. So if you see till this point in the first octet, we have all matches, right? All matches. Can you see that? Matching bits we have. In the second octet also we have same matches. So there is no issue in the first and second octet. All we have a matching bits. Right? All we have matching bits over there till this point. In third octet, if you have a look verify, these bits are matched. For the 2, it should be 1. So we go with the 0. And it's only 3 for the 1. If you see the third octet, we have matching bits are till this point. Right? We have matching bits till this point. And we have matching bits till this point. So this is the border point we have, if you see that. This is also matching it, right? This is also matching it. So this is the border point we have. So what you can do that, if you convert all this guy, or simply I can tell you what you can do that simple way. Step 3. Not remaining bits, convert all the leftmost bit into ones. So if you see, if I convert all this leftmost bit in the ones, what happened? I will say that 1, 4, 5, 6, 7, 8, then 4, 5, 6, 7, 8, then this is start from here. Then we have a this bit, this bit, this bit, this bit, this bit, right? And then we have a 0 and 0. Right? So if you add all this value, if you see that same bits we are converted, right? Till this point. Into the ones. So the value of this guy is what? The value if you add, you will have a 255 over there. Then you have 255 over there. And if you're going to add all this value, you will get the 128 plus 64, 192. 192 plus 32 will be 224. 224 plus 16 will be 240. 240 plus 8 will be 248. 248 plus 4 will be 252. So the subnet mask will be what? You have a 250, 255.255.252.0. Simply. And now, so the binary address will be what? So the summary dot will be what? Now the summary dot will be 192.168.0.0. That's gonna, this section 0, the third octet we have, it's gonna match the 1, 2, 3. And I can call the summary mask will be what? .0. So what you have to go, you need to just go under the interface 0/0, and say that, hey, listen, the protocol, because EIGRP works on the IP protocol, also the IP keyword for the EIGRP number 1. Sorry, IP summary address. I want to convert this out into the summary one. What is the summary address? We have 0.0. Submit mask will be 252.0 for the EIGRP protocol number 1. And that's all. Hit enter. So once I say this guy, hey, I need to convert all this 3 dot into the ones. For which protocol? EIGRP number 1. So this is the summary address that I'm going to create. So after doing this thing, what happened? Now the router 1 is going to send this information to the router number 2. Which information? They have a summary dot. 22. 252 is going with the 22, right? So now the router 1 is not going to share this information. He will share this information, summary router information. So you can do that same practical. What I can do that, I'll go with the new lab. Two is enough to just verify this thing. Okay, so this will be, I'll consider this as 201. And I have a loop back over here. Right? So on the router number 1, we are going to do the summarization. So you will see the summary dot on the router number 1 with the ED5. But when the router number 2 is going to receive it, it will become an internal router. So in the router 1, also I put the IP address. Done, right? So router 1 has done. Router 2 we have. Perfect. And here we go. All done, man, right? So let me copy on the router number 1. All good. And can I connect the ring? Oh, wow. I do have router 1 is also open. So router 1. Bingo. And how the router number 2 now? So on the router 2, if you see, I have a EIGRP configuration. Oh my goodness. So everything is working fine. Now you can see that one thing. If you check out the do show IP root EIGRP, I have all these 3 routing table. That has an internal route. It is a 90. If you see the do show IP root summary, what you will get that you see the 14, 16 bytes of memory right now I'm utilizing. It's crazy, right? It's a before summarization. I'll put this guy as a before summarization, and then I'll show you the output of the after summarization. Summary. Now what I can do that, you just need to go on the router number 1, and I'll put this command, interface 0/0, IP summary address, EIGRP number 1, and the summary address will be 252.0. Hit enter. So on the router number 1, if you see, you can see the summary has configured. So on the router number 1, you will see that what? As a AD5, that's called as a summary dot, also known as a supernating. why we call as supernating? We are reducing the size of subnet mask information. When we are increasing the size of subnet mask information, like a 10.1.1.0, normally this is the class A dot. When we are increasing it, it's called as a class less dot. But when we are decreasing it, right, 1.0/24 into the /22, it's called as a supernating. Can you see that? This 3 dots converted in the ones called as supernating. It's called as the internal dot. If you see the mat ED will be 5 for this guy. So this is the summary dot, but majorly EIGRP only has the 2 types of dot. One is called the internal and external, but AD is a 3. Summary 4 has a AD 5. But when the router 1 is going to advertise this route to the router number 2, it seems like a EIGRP internal route. So for the internal route, what will be the AD value? 90. So if you see do show IP route EIGRP, previously I have this information, all these 3. Now it's bingo. So now you can see the same output I can bring you over here. You can see the beautiful output now after summarizing. I can see my CPU man previously overhead was 372, now it's 204. So routing table size is reduced now. It's only 1 dot. Previously I had a 3 dot. On data number 2, you will see the 9080. 90 means what? Internal out.
Okay.
On data 2. But on the data 1, distance 5. That comes like a EIGRP summary. Questions, guys. I'm done for the today. So all these 3 dots we have done. Okay, why the some AD has a 5 for the summary dot? There's a big explanation on this one. When you go for the CSI, you're going to understand the concept. So just for a hack of the, I'll tell you, if 85 is preventing data plane loop and null 0 so whenever you do the summary route, so it basically create the null 0 route, or we can say the null 0 interface we have, make it the null 0 route. Or so normally people are call as a null 0 route, but I normally call as a null 0 interface. So because traffic is hitting to the interface, right? Null 0 route prevent. No, this guy is gonna prevent the control plane loop, not the data plane, sorry. Control plane, and this guy's gonna prevent the data plane. So yeah, but it has almost 3 hours of the experience around this part, 2 hours at least. So you can see that we have null 0. So personally, I call this guy the null 0 interface, or they can call that null 0 route as well. So let me write on this guy as a slash say interface out there. Questions, guys?
Hi, it's just the quick question about the when you combine all 3 different IPs into the single /0 network, right? You mind to just repeat that a bit later again when you the 3 subnets into the single subnet.
Okay, how did I do that? This
Yeah,
one?
I mean,
It's a basic one. I just convert the
Yeah,
binary of this guy.
no, that's fine. No, that's fine. I understood this is the
Okay,
binary part you converted for when you converted into the
this one, right?
yes.
So convert all the leftmost bit into the one. So whatever the leftmost bit we have into the ones. So till this point, it was the same values, right? Can you see that? Till this point, we have different values over there, different values over there, different values over there. So left the 2 bits, convert into the ones. So, and if you're gonna add all the value of the ones, you will get the 252, 255 for this guy, 255 for this guy, and 252 with this guy. So first octet, second octet, and third octet. Got it?
So if we leave the last 2 bits of all the 3 subnets in
Right.
step
So
number 2,
yeah, so
yeah.
if you're gonna add this guy, it's a 128, 64, 32, 16, 8, 4. How much we will get?
No, that's fine. That is fine. That's 252. That's fine. Okay, but so you have basically excluded the
All the match
last.
bits till the match.
So I mean 192, 168. That's it. You
Right.
have
Yeah, the third octet, we cannot put any number over there, right? Because one has different, two has a different. So I'll put the 0, put the common.
right. So and you just
Yeah, tell me. You missed somewhere?
so the third one is 1, 2, 3, right? In all the 3 different subnets.
Right.
Okay, but you have 252. It is a third, isn't it? Right?
Sorry?
252.
252. Yeah. So this is the subnet mask. How did I get this one?
To actually convert
See,
a
I
physical
just
SIM,
converted
if
all
the
this
network provider
guy
can
into
actually
the
convert
ones,
a physical SIM to an
right?
eSIM,
So I got this value.
with options are on iPhone.
Okay.
So you can go into it, if you on your phone, go to settings, go to mobile data, tap to convert to eSIM.
And then ask it, can you hear me?
Go on to eSIM.
Yeah, I can hear you. Yeah, I'm trying to understand. Yeah, I can hear you. Yeah.
So what I did, I'll just convert all these 8 bits we have,
Mobile data,
8 bits
tap
we
it,
have, and
it
6
comes
bits
up
we
to
have.
tap to
This
convert
value,
to
right?
eSIM. That's some smart service, isn't it? Only on an iPhone, that is.
Okay. Yeah. So 255, right?
Yeah.
For the that is for the
Don't tell Joe that.
first 6,
First and second octet.
first and second octet. Correct.
The
Yeah.
third octet will be 6 bits we have. So the 6 bits, what's the value you will get? 252, right?
Yeah, but how did you get the 6 bits? That is the question. That was the question. How
Okay.
did you get the?
Convert all the leftmost bits into the ones. How many leftmost bits we have? That are the matching bit. Till this point is the match bits, right?
Hmm?
Can you see the matching bits we have?
Well, physical SIM to an eSIM.
Yeah, that's for the 255. Yeah.
Understood?
192, 160. Yeah, one. Yeah. So yeah. So the third octet, what you have done is just you minus that one from the 255 basically,
Right.
and just converted all 3 uh, different subnets into the one as a one summary root.
Right. That's a base number, 0 that I use that.
Okay, and
Only
this
all
is
the
called
matching bits.
no, not all of them. No. The matching bits is will be considered as a 255, right? The first 2 octets.
So
192,
No,
160.
we converted
that's what
all this
he's
match. See, the first octet is matching, right? Can you see that?
Yeah. 192,
Yeah. Forget the 192. It's matches bits.
255.
All,
Yeah.
forget the match bits. It's all matching, right? You see that?
Yeah.
So convert all the it's matching bits into ones. Same thing. See the second octet is also matching, right? It's converted also. in the third octet, we
Okay.
only have a 6 bits matching, right? So I convert the only 6 bit into the ones. Remaining this 2 bits are not matching, and this is 0, 1, 1, 0, 1, 1. It's not matching. So I'll leave it as a 0. So this
See
is the
what you
bottom
mean.
point we have.
Okay, so the bits which are not matching, right?
We need to ignore, put as a 0 over there.
We'll put as a 0. Okay, that's fine. And what about the fourth one?
Fourth one, there's nothing. It's no, we don't need to do anything in the fourth octet because we are not going to deal with the fourth octet. Can you see that? It's only we have third octet. The subnet part is a third octet, right? Host part is a fourth octet. We are not going to deal with the host part. We are only going to deal with the network portion.
Well, they're all going to come live.
Class C fourth octet is a host IP address, right? So we are not going to touch the host part.
Oh, that's all right.
You understood, Nasir?
So, okay, I see. So basically, unmatched bits will be calculated as right into the one
Match bits
network.
are calculated in the ones, not the unmatched.
No, no, I'm talking about the first way. I'm talking about the match. That is fine. That's been done, right?
Right.
255. Yeah, 255. Then again, in third octet, first 6 bits are matching. That is fine.
Right.
And the last 2 bits are not matching.
No
So,
matching. So I convert in the 0.
You have converted.
Yeah. Or either you can do in this way as well. But I can do that
Just that one. Yeah.
in this way as well. If you
Two
want to
that you've got,
understand.
that's the only one that works for me. The plug. That's very great.
Mute
that
you.
don't work.
I'm getting the
I'm not
battery.
sure which other audio.
Shall I
is
bring this
on.
bit as well, or shall I leave that?
Yeah, all
You can do that step number 4. What? So already already the class C, if you see that in the class C, this 2 1 is already as a 255, the 255, right? Right? We are not going to do anything. In the third octet, what we have, the 6 bits we have, right? So only in the third octet, because in this third octet, we can see that just if you look for the third octet, because we are not going to do anything in the first 2 octet, right? Because first 2 octet is the same values. Leave it as third octet, if you see that, then I can do in this 6 bits, we are converting, right? 6 bits into the 252. I'll convert the 6 bits into the ones over there. Understood? Nazir, you got that now? Hey, are you there? That's he's not there. Okay, so I'll save this note back.
Sorry, I'm here. I think I put mute myself. Sorry. So basically, what happened is on third octet, we just add up the first 6 bits and we add up all into the convert to the decimal forms. That will be
Exactly. So I convert the decimal format.
it will be as a like a
So if you
252.
know, if you don't do like
Yeah.
this, if you want to make a step now to convert
Yeah.
all the bits into the decimal format.
Yeah, convert to the decimal form. That will become the 252. That's it. Simple.
Simple. It's all about
The
the
last-
submitting. It's all about the submitting. Nothing we are doing new things.
And the last bit will be the 0, right?
Yeah.
Okay. Okay. No
Because the fourth octet we have, it's only for the host person, right? So we are not going to touch the host person.
No problem. That's absolutely fine.
Got it?
Yeah, got it. Thank you so much for that.
Okay, no issue.
Yeah.
So we are done with the route text of the EIGRP, guys. So now tomorrow we'll move to the little bit high level of stuffs for the EIGRP, right?
So tomorrow is our last.
No,
last for the.
no. We have a lots of things, man.
No, I'm talking about the EIGRP.
No, not yet. We are gonna finish the EIGRP on the Friday.
Okay. So that means, so basically there's more to learn in the EIGRP.
What do you mean no EIGRP? I didn't get your question.
No, you were saying that we will be continuing, and I'm saying that
Yeah,
means
we are
have more
we are
to
gonna
learn in
continue the
EIGRP.
EIGRP. We are gonna continue tomorrow, day after tomorrow. We need a 3 more. I need a 4-5 hours classes or more of the EIGRP.
Nice. Then we may have to tighten our belts.
Yep. So normally in the CCI, yeah, Nasir, I'll give you. So normally in the CCI, we have a EIGRP of the 25 hours of the session. So when I take for the CCI classes for the EIGRP, so we have a 20 to 30 hours of the session for the EIGRP.
Wow.
SPF for the 30 to 40 hours. And BGP also have a 40 hours, 30 hours session of the BGP too.
Okay.
So yeah, but CCNP, if I go through that level of the deal, you will not understand a lots of things with the flags level and those things. Okay, guys, I'll catch you tomorrow.
Have a good day.
Have a good night,
Okay.
everyone. And one more
Alright.
thing. So RIP protocol videos, I'm gonna upload on the YouTube channel. My older videos will be there. I need to check my drive. So I'll put the RIP videos on the YouTube channel. If you want to learn the RIP protocol, you can learn the RIP protocol from YouTube.
Okay.
So you mind to share your YouTube channel again, the link?
Okay.
Please?
Moment.